Hello all, today in this video I am going to provide the details of the optimizer with RNN. Previously, this is a continuous variation video. Previously we have worked with some activation functions, and in this code we are going to work with adamax optimizer. So for that, initially we are importing the libraries which we are needed. Then we are loading the data set. Here we have used the heart disease dataset. This dataset we downloaded from Kaggle. You can just give us heart disease dataset. Kaggle means you will get this dataset. This dataset is having nearly 14 entries. Among that, the first 13 entries we will be using as the x variable, and the last entry we will be using as the y variable, which is the target one. Then we are getting the info of the dataset. From the info of the dataset, you may notice that only the whole peak one is the float type and all others are integers, and then we are checking whether our dataset is having any null values. You may notice that everything is 0 only. In this case, the dataset is not having any null value, so we are not moving any pre-processing functions. But if it is having any null values, means we have to work with some pre-processing functions. Then we are displaying the heat map of the dataset. So this is the heat map of the heart disease dataset which we are using. Then we are determining the x variable and y variable. As I said previously, within the x variable, among the target variable, we are using every others within the x variable, and for the y variable, we are using only the target one. So for x variable, we are dropping the target one, and for y variable, we are using only the target. Then by this use of x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. And by the use of this train test split function, we are determining variables like xtrain, xtest, ytrain and ytest. Then by use of the standard scalar, we are making the conversion of vectors within the variables like xtrain and xtest. Then we are getting the shape of the data. Why? Because this shape we will be using within the input shape of the layer contribution, and most deep learning algorithms will be working with only three-dimensional data. RNN algorithm is also one such among them. So we have to convert this three-dimensional data into two-dimensional data into three-dimensional. For that, we are using this reshape function. Within this reshape function, we are converting this two-dimensional data into three-dimensional. This three-dimensional data only we are using as the input shape within the simple RNN layer, and then the activation we are calling as a ReLU. Then the final dense layer is declared. Within that, the output dimension is 1. Why? Because our work is a binary classification work. If we are using multi-class classification work, means this output dimension will be replaced by the number of classes which we are working. The activation we are giving a sigmoid. Then we are getting the summary of the data. So this is the summary of the data. Then we are compiling our model. For that, we are using loss optimizer as Adam. If we are in case of other optimizers, the only difference we will use is we will replace the other optimizer's name which we are using in this place of optimizer. Matrix is accuracy. Then we are training the model by using the fit function, and the variables like xtrain, ytrain, xtest and ytest. For approaches 50, for 50 approaches we are getting the value of loss, accuracy, validation loss and validation accuracy. Then we are displaying the classification report. Within the classification report, we are getting values like precision, recall, F1 score, support, accuracy, macro average and weighted average. Then we are defining the confusion matrix and also plotting the confusion matrix plot for RNN Adam. Next, with the XDD optimizer we are working. So already I said that With every optimizers, the only difference we will see is the optimizer. So previously it will be Adam. Now we have changed for as SGD. It is also working for 50 approaches, and we have displayed the classification report and also the confusion matrix. Same with rmsprop also. We are replacing the optimizer value, and then we are working for 50 approaches, and we have displayed the classification report and also plotted the confusion matrix. Then we worked with adadelta optimizer. This optimizer place is replaced by adadelta, and it is trained for nearly 50 approaches, and we have got the classification report and also the confusion matrix. Then we worked with adagrad. For that we replaced the optimizer with adagrad and trained for nearly 50 approaches, and then we have displayed the classification report and also the confusion matrix. In this work we are working with adamax. So all the layer contribution will remain the same only. The only difference is the optimizer one. There we will be replacing with adamax. You may notice that we are worked or trained for nearly 50 approaches, and then we have displayed the classification report and the confusion matrix. Then we are making a comparison graph for all the optimizers which we have made. So we have made this graph with the variables like or parameters like validation accuracy, training accuracy, validation loss, and training loss. Here you may notice that the optimizers like Adam, then rmsprop, and this adamax and the rmsprop and this adagrad is providing some better results. All others are less only. And when you notice, well, every algorithm is showing some deviations, but this ada delta is same within the 0 approaches and also with the 50 approaches. So this is making sure that for every with the other algorithms, while the approaches are increasing, the values are also increasing. But for this, that is the ADA delta, with increased approach, there is no such change. So in the next video, we will be working with some other optimizer, which is an Adam, and we'll make an comparison regarding that. Thank you.